Okay, here's the third video for chapter 1. So scientific notation and dimensional analysis. Scientific notation is a good way of working with really large or really small numbers. A quick review here is if you have the value 5,000, you would move the decimal point over until you only have one digit to the left of the decimal point. So I would move the decimal until I have a 5 times 10 raised to an exponent. The exponent tells how many times or how many spaces the decimal moved. In this case, it moved 1, 2, 3 times. It would be a positive 3. Whereas 0.005, I still move the decimal until I only have one digit to the left of the decimal point, so 5, times 10 to the negative 3. So negative 3 indicates that I have moved the decimal point in the other direction. The way I remember this is if the original value is big, meaning 5,000, for example, if that original number was greater than 1, it's going to be positive exponent. But if the value was less than 1, it was some decimal, then the exponent will be negative 1. So if you think of a number line, the negatives are down here for small numbers, and the positives are up here for big numbers. Okay, we work with equalities and conversion factors a ton in this course. So this next section is probably the most important thing here in chapter 1 to understand. Equalities are just things that are equal. So 1 meter is the same thing as 100 centimeters. 1 minute is the same as 60 seconds. How we can convert is by using this general formula here, where you start with a given unit, and then you use a conversion factor right here, which is a fraction. Okay, the given unit has to go directly to the bottom of the fraction so that it will cancel, and the desired unit will go on the top. This will cancel given units and end up with the desired. Here's an example. How many inches are in 1.40 feet? So if here's 1.40 feet, that's our starting value. Immediately in our conversion factor, the unit feet is going to come to the bottom. So feet comes to the bottom, and we're going to convert to inches like we're wanting to do. Then we put in the values. So we know that 1 foot is equal to 12 inches. That's how we knew where to put the numbers. Then what you do is multiply everything on the top and divide by the bottom. So 1.40 times 12, divide by 1, and you get 16.8. Sig figs wise, the conversion factors are pretty much always going to be assumed to be exact. I'll tell you when that's not the case. So you don't look at those sig figs. You look at your beginning measurement. 1.40 has 3 sig figs based on our rules, so our answer can also have 3 sig figs. Another example, if a woman has a mass of 115 pounds, what is her mass in grams? It gives us a conversion factor over here, inequality. We start with 115 pounds. Immediately in our conversion factor, pound, the unit, has to come to the bottom. And we're going into grams. So we put pound on the bottom, grams on top, and then we fill in the correct numbers. The 1 will not always be at the bottom. It just happened to be in both of these examples. But it said 454 grams is equal to 1 pound. You multiply the top, divide by the bottom, and we get our value. So here we started again with 3 sig figs. We need to take this down to 3 sig figs. So we can keep the 5, the 2, and the 2, but we can't just say 522. We still have to recognize that there were 2 spaces here. So what we do is we keep the 5, 2, 2. The 1 tells the 2 to stay, and then we replace the 1 and the 0 with zeros. So 52,200 grams is 3 significant figures. You, of course, could change it to scientific notation as well and make it 5.22 times 10 to the 4th. But don't include the zeros, or they will be significant now that there is a decimal place. How many minutes are in 1.4 days? So here we've got 1.4 days. We are trying to go days to minutes. No matter what you're trying to do, you take this original unit, days, and put it on the bottom. So that's why I have the arrow for days. Now, I don't know in my head how many minutes are in a day, but I do know that there's 24 hours in a day. So I can do this in multiple steps where I have a day on the bottom. 1 day is 24 hours. So I've gotten rid of the unit day. And if I stopped the problem here, I would be in hours. What I can then do is hours is now on top. I bring the unit hour to the bottom. so that it's going to cancel. And now I can get into minutes because I know 1 hour is the same thing as 60 minutes. So I multiply every value on the top. I divide by every value on the bottom. My calculator gives me 2016 minutes. And I know that my units did what they needed to do. Days went away, hours went away, and I'm left in minutes. 2016 has 4 sig figs currently, and I need only 2. So this is a little bit of a trickier one because I need the 2 and the 0 to be significant, but not the 1 and 6. So generally what I would do is the 2 and the 0 would stay, and I would replace the 1 and 6 with zeros. But then that would be 2000, which would only have 1 sig fig. So in this case, I have to go to scientific notation and make it 2.0, that's 2 significant figures, times 10 to the 3rd, because I've moved my decimal 3 times. And then the last example there, how many milliliters are in 0.860 gallons? And I have a couple of conversion factors given here. So I start with my given gallons. Immediately I take gallons and put that unit on the bottom. And I look at my given conversions. Well, gallons to quarts is given to me, so I'll go ahead and go gallons to quarts, a 1 and a 4. But that's not where I'm supposed to be yet, at the end. Here's milliliters, which is what I'm trying to get to. So quarts will then be pulled down, and I'll go from quarts to milliliters because I'm also given that conversion. So I multiply all the top values, divide by all the bottoms, make sure gallons canceled, quarts canceled, top and bottom means you cancel, and I'm left in milliliters. Here's what my calculator gives me, but then I have to reduce it to 3 significant figures. You have both options of scientific notation or not there. So prefixes are also really helpful when you're working with really small or large measurements. So the metric prefixes are listed here. You don't need to memorize them, but you do want to pretty much have kilo, centi, and milli memorized at least, because they are going to be used so commonly. But we'll run into all of these. These prefixes can be used with the metric system units, so seconds, liters, grams, and meters. You'd never hear these with something like inches, but you could have a megaliter, you could have a megagram, a kilogram, a centigram, a centimeter, a millimeter, etc. Here are the conversion factors. So what that means is the prefix stands for a power of 10. For example, 1 micrometer, micro, that little u thing, a mu, is equal to the 10 to the negative 6. So you can see these two values, top and bottom, are equal. One has the micro, that's a prefix, and one has 10 to the negative 6 because that's what it stands for. This got a little cut off, but all I did here was take this and switch it upside down. 1 micrometer on the bottom, 1 times 10 to the negative 6 on top for meters. Because values can always be turned upside down. You just have to take the correct value and unit down, value and unit up. The more common ones, you may want to use just the normal conversion, meaning kilo technically stands for 10 to the 3rd. But if it's easiest for you, you can think 1 kilometer is 1,000 meters, just like 1 kiloliter will be the same as 1,000 liters. Here for centi, 100 centimeter or 100 centigrams are in 1 gram. Milli is 1,000, so 1,000 milliliters in 1 liter, or 1,000 millimeters in a meter. Here are some examples of conversions using these. 65.8 centimeters. Immediately the centimeter has to go to the bottom as a unit, and I'm trying to get to meters. So I then think, what is my conversion here? Well, 1 meter stick has 100 centimeters. So I set that up, I multiply the top, divide by the bottom, get my answer, and check my sig figs. They should always match the beginning measurement. Okay, 452.6 milliliters. I take the unit milliliter, put it on the bottom. Milliliters into liters. I know that 1 normal unit always has 1,000 millis, because that's what milli means. So if I have 1,000 milliliters, I'll end up dividing by 1,000. Here's my answer, and I'll check my sig figs to match the beginning. 4.50 kilo. Now here's another, a little bit different example. Here what we're doing is we are going from kiloseconds to milliseconds. So what you'll notice the difference is we're going from one prefix to another prefix. My recommendation is to always get rid of a prefix and then get to the next one, meaning go from kiloseconds to normal seconds, and then go from normal seconds to milliseconds. I see less problems or careless errors when this happens, when we do it this way. So we start with 4.50 kiloseconds. The kilosecond comes to the bottom, and the seconds comes up top. And I know that 1 kilosecond is big. It consists of 1,000 seconds. So I've succeeded in getting rid of kilo. I'm now in normal seconds. So I bring seconds to the bottom and I convert to milliseconds, which is 1,000 milliseconds in 1 second. So I multiply the tops, divide by the bottoms. I get 4,500,000 there. That is only 2 sig figs. And I made another error right here. The original value here has 3 sig figs, 4.50, if you agree with me. So 4.50 has 3 sig figs. We need to have 3 sig figs in the answer. So the correct way to write this answer would be 4.50 times 10 to the 6th. I'll update that in the filled in units, or the filled in notes. Okay, other prefixes. So those were just the most common ones, the kilo, milli, and centi. The others, let's look at how they work. So remember again, the prefix stands for a power of 10. So 1 gigameter equals 1 times 10 to the 9th meters. And you can set those on top of each other because they're equal. 1 gigameter is the same as 1 times 10 to the 9th meters. Or you can turn it upside down. But see, you're having a prefix, either top or bottom, and the power of 10. Those are equal to each other. So one is on top and one's on bottom. For example, 4.5 meters is how many megameters? So we start with our meters. Normal meter comes to the bottom of the conversion factor, and we put megameter on the top. We go back to our table and we see, what does that big capital M stand for? Well, it stands for 10 to the 6th. So 1 megameter is the same thing as saying 1 times 10 to the 6 meters. When you divide by scientific notation, you have to use parentheses in the bottom. So what I mean by this is, in your calculator, make sure 1 times 10 to the 6th, or 10 to the 9th, is put in parentheses. And I'll have to double check here that I think I made an error right here where, oh no, mega is -6. I was looking at giga. Giga is 9th, mega is 6th. So that's why this is 1 times 10 to the 6th. Make sure that bottom value is in parentheses and that you're getting the correct answer here. We started with 2 sig figs and we're ending with 2 sig figs.